Hey everyone, welcome back to the Whiteboard app series. In today's video, we will save the path object into the local database as a string. And remember, if this video hits 50 likes or 50 comments, I will drop the next part of this series. So let's dive in. Here is our whiteboard database and we have two tables, one for this room master table and next we have this path table, and we can open it and we have some data. Right now we only have two things. First, this ID, this is auto generated by the room library itself. Next we have this drawing tool and we also have this starting offset saving into this database. So this is how the room database will work. But here few more things we need to correct. First thing, if I open the app again, then we can see we have lost those paths we created. This is because in our whiteboard view model, we are just inserting the path data into the database, but not retrieving the data from that database. So we will do this thing next. First, let's minimize this app now and close it also. And first thing, let's close these files and go to our path repository. And here, this path repository is part of that domain layer. And this interface will always need to use the models we have defined in the domain package, this drawn path. So we will update this function with that drawn path. And next thing, here our repository implementation is giving error because these DAO functions required the path entity, but we are providing the drawn path data class. Let's also change these. And to provide that path entity to these DAO function, we need to create the mappers functions. So here in our data package, let's create one more package with the name mapper. And here first we will create the path mapper. And first let's create an extension function on this drawn path. And let's name it to path entity. And this will return us the path entity. And let's also modify this path entity. We will not simply save the starting offset, rather we will save the actual path from this compose UI graphic. And now let's map it again. And one more thing we need to update is here in our drawn path, let's also keep an ID of type long, and also we can map this ID. And let's also define a similar function, but this time this function will be on this path entity and it will convert the path entity data to this drawn path. And also this will return us this drawn path data class, and everything else will be same. And we can here pass this path, and let's convert this to the entity with that to entity function. And same thing we need to do here. And let's also modify this function in our interface. This needs the drawn path. And in our implementation again, let's update it. And here we cannot simply use this to path entity function directly because this is a list. So let me create one more function on the list. And let's use that function here with this map 8.2 drawn paths. So now our implementation is not giving error anymore. Minimize these imports and close this file. And next thing here I need to discuss is, here in our path entity we have specified that we need to save the whole path object into that database, but we cannot do so. Here in the SQLite database we have simply just a table where we keep the data. So in that table we cannot keep some complex data. Rather we can keep simple data like strings, boolean, long, these values, but whole object we cannot save. But you might say that why we are able to save this drawing tool enum class into that simple table. Here the reason is that room library will convert that drawing tool enum class into simple string values with a converter function. And we can check this by pressing Ctrl B on this drawing tool, and we have a path.dow implementation. This is the generated code by the room library. So let's click on any of this, and here we have some functions, and I will show you a function where they are converting those. Here are those converter functions. What they are doing, they are converting those drawing tool enum class into a simple string values like this. In the same way, they are also converting that string value into that enum class value. So with the room library, they just provide this functionality for enum classes. But if we have some different object and we need to save that into that database, then we need to define a converter function manually, like they are doing here. So let's close this, and in our local package here let's create one more package with the name converter, and create one class with the name path converter, and this class we will use to convert the path into a simple string value and also from that string value to a path object. First thing here, let's define a function which will convert the path into the string and name it from path, and it will take the path and will convert into a string. And in the similar way, let's define one more function, toPath, and this will take the path string and will convert into a path object. And both these function we need to annotate with this type converter, this singular one, and same this. And make sure you are importing this singular type converter, and this path converter we need to specify in our database class that we also have a path converter. And here for that, here we have an annotation with the name type converters, this plural one, and provide our path converter class here. Now our job is to create a function that will convert the path from and to string. And how we will convert this path into a string? For that, go to this compose resource package and any of these files, because all these files are SVG, scalable vector graphic. And let's open this file. And here see this path data. These SVG files also draw the shapes using a path, and that path data they keep as a string. So we also need to save our path object in this SVG format. And if you want more understanding on the SVGs, how they keep the data, I have one website, this path SVG visualizer. Suppose if we have a simple line, so how we define a path of this? First we define the command with this M2. So here we are saying that pick the pen and move it to this coordinate. and from here the line will start, and all these path concepts are exactly same which we used to draw the path in our Android canvas. And after this m2 command, next command we have this l command. So this l command specifies that we need to draw this line to this particular point. And if we check the path of this triangle, here first we have used this m command from move to, and next we have this l52 command for making a line to this 52 coordinate, and after this again we have this l88 command for making the line to this 88 coordinate. And this is how we specify the SVG paths. And if we have curve, then we use this C command for cubic 2. And in the same way we will specify our path data into a string. So here let me create one private function with the name serialize path. First let's create a string builder, and next we have this path measure from the Android Compose UI graphic. And as the Android Studio is suggesting, first we need to use this set path function, and next we will use this length value to get the length of this path. So this will be our function. Here we are simply saying if we have the first point, then we will use this m command with these two coordinates, and for every other points we will use this l command for line 2. And after every point we are adding the 5 as the distance. So this will be our function to convert that path object into a string. And next thing, let's also create one more function for deserialize this path. But to convert an SVG path into a path object, we already have a path parser from the Android. So here let's first use the path parser, and we have the path parser, and we can use this parse path, and we will provide our string, and we can return the path object with this, and let's use both these functions here. And this is how we will convert our path into a string. Hey everyone, if you are finding this tutorial helpful, you will love my premium Udemy course where we will build Measuremate, a fitness app using Jetpack Compose. We go in depth on the Firebase authentication, Firestore, and more. Check out the course in the description and take your skills to the next level. See you there. Now we can close all these files and go to our whiteboard view model, and we are getting some error. And here in our view model, in the update continuing offset function, we are saving the drawn path into this current path state. So after completing the finished drawing, we can insert that path from the state. And we also need to update this insert path function. Here we will provide the path of this drawn path type, and we will provide that path to this function. but it is showing that the value we are providing is null, so we can just wrap inside this let block. And here now we don't need to add those path here, but rather we will simply update this current path to null after successfully inserting this drawn path into the database, and we will get the list from the database. So here let's use this combine, and this will combine multiple flows. First flow we have this for the whiteboard state. We can see mutable state flow. And next we have the flow from this get all paths function. So let's combine both these, and we have the state and paths. And from this state we will update it these paths value with the new value. So this is how we update these list of paths from in the state. And after this we need to use this state in function to convert this flow into a state flow, and we can use this code. And this is how we get the paths from the database, optimize our imports, and now we can run our app. And we got some errors. This error is because we have changed the schema of our database, and we can see here in this entity earlier we were saving the starting offset, but now we are saving the path. So we have changed the schema of that table. So we need to define this thing. First thing we need to update is this version. Now our version will be 2. And next thing, in our get room database dot android file, we are defining the how this room database will be created. So let's also define one more thing, this fallback to destructive migration, and we can pass this drop all tables to true. So whenever we will update the schema of the database, then we need to update the version, and whenever the room will find the updated version, then it will clear all the past data. Now the room will save only the new data. And also we have specified that drop all tables. Whatever tables earlier it has, it will drop all those table and it will create the new tables. Same thing let's also define in that desktop file here and run it again. And here is our app. Now let's draw some paths and also with some other tools. Now close our app and open it again. And here we have all the paths we created and closed the app, and now we have the paths. And if we check the database, and this is showing the closed, but let's close the app so it will download all these data into that offline mode. And here we have the data. First we have some IDs, and next we have the drawing tools, and in the last we have the path data. And we can see this is how the path data will be saved into that database. Now our Android app is working perfectly fine. Let's also run this app on the desktop. So this main.kt file, let's run it. This is giving error, but we will run our app from the terminal. and we got some build errors. So let me check the error. So the issue was, let me show you. First let's go to our DI platform module. So here we have a expect function, this platform module, and we need to provide the actual implementation for both the platforms. For that we press this Alt Enter and this add missing actual declaration, and this is saying we need to add the desktop main. So let's select this. So it has created this file, but when we look into our desktop main package, then we can see there is no such file. So what is happening? This Android Studio is generating this file not in this desktop main but in the generated folder. Here when we go to this build, generated KSP and this desktop main, and we can see here we have this DI package and this platform module.desktop.kt file. So let's cut from here and paste in our desktop main package. Now let's call our getRoom database function. So coin will create the object. Now we can run our app, and here is our desktop app. Now let's also run our Android app. And here is our Android app. And these drawings are from the last time, and we can draw anything. And that's it for this video. As always, if you have any question or suggestions, feel free to drop them in the comments below. And don't forget to hit that like button and subscribe if you have not already. And I will see you in the next video.